Okay, good afternoon everyone. So we'll start the session. Can anyone please say, confirm that like my voice and screens are visible or not? Okay, so today today will be the last session from my side, and the for the course also. I think for you next week 24 will be having the exam, and today I'll be taking the brief of whole course that will start from the first week. That first week that like we have to introduce with the experimental design that is a strategy, then binomial distribution, Poisson distribution, then normal distribution. And I have not made like a dedicated PPT, but will show from here to there. Then we'll go ahead with that, and whatever the doubt you will be having, you can ask. And some question that second week, some 7th number question that I'll solve, and some how to see the jet table or either how to get the F value from that I will also show you. And in the second week, we were having that standardized normal distribution, then T distribution. Then we'll do some statistical test, a statistical test for a small number of sample like T test. Then we'll go for the F test, like we have to go for the higher number sample. Or then if we have multiple input and output, then we have to go for the ANOVA testing. In ANOVA, we'll be having one-way ANOVA and a two-way ANOVA. Once we have done with that, so in all the tests, that parametric test, we have to assume that the data are normal. So we have to do the testing for that normals also, and then we'll see what are the test for the normal test. Like then we'll discuss about some point estimation like odd ratio, and then we'll discuss the non-parametric test like viable distribution, then non-parametric test. Then test for that homogeneity of the variance beta distribution. In the 7th week, we'll have a design of experiment. Why we do we need to design the experiment? What are the type of design of experiment? What is the uh, advantages of the design of experiment? Then what are the type like factorial design, full factorial design? Why we have to go for the from full factorial to the fractional factorial design? And then we'll see some other types of design that is specific to the any of a specific problem. Once we'll discuss about that one, so then we'll discuss the second order design and then first order design and regression analysis and then control chart. And finally we'll come up with that regression. So whole course objective was to get the better understanding of that statistic and the design of experiment. When we are doing any of that experiment, that might be the bio related, or even though if you are in the core engineering branch, so we have to do the experiment for validation and all the thing. And in the core, sometimes we sole experiment itself that we can publish. But the thing, once you come to the biomedical application or as a biotechnology, so we have to go through with all statistical method to validate what are the assumptions we are taking, what are the hypothesis we are assuming. Based upon that, we have to validate it, and that validation that can be done with the help of a statistical method. In if we say the core engineering, if we are not doing a statistical test, so it's like the qualitatively and quantitatively based upon that experiment we have will give the data that is acceptable in that many population and all the thing. But if it is come to some sort of trials, maybe the drug manufacturing or maybe that fertilizer manufacturing, or in the case of maybe that bio problem, so we have to validate with the biostatistic, and then we have to assume some hypothesis. Based upon that, we have to make the interpretation, and then we have to come forward. So in the first week we'll start, I will show my first week PPT itself. Okay, so actually why do we need to do the statistic, like what is a statistic? So shall I just brief, or either will whatever doubt will solve? Any idea that how we should go ahead from here? Can anyone suggest? Okay. Okay, fine. I'll just briefly go with all the distribution where to apply, and then I'll give some that formula for all the distribution test so that it will get brushed up before the examination. Okay, so before starting the biostatistics, we have to know what is the statistics. So it's a that science that is going to tabulate in the numerical data or expressing the result in a mathematical and graphical form. And that biostatistic is just a statistic application in the biological event. That biological event can be anything, that may be the drug manufacturer, or either maybe that any of the drug trials also. So if that is related with the bio, and in that case, or maybe that will be the human and then animal itself. So that also, for that particular type of study, we'll say biostatistic. Okay, so we all know that what is the constant. That constant does not vary in biostatistics. That means standard deviation, that will be the always constant for the population, and the variable, that is the vary with that with respect to the time also, maybe with the persons also, maybe that means that thing that will change according to the parameter. Maybe that we can say the person, the place or thing, like the height also, the weight also, blood pressure also, maybe the effectiveness also, or the efficiencies also. And the parameter is again, we have two terms, that variable and attributes. Variable, usually we are saying the countable, and then attribute, that can't be countable, but it's like we are giving into some categories or classes. And the parameter is like describe a population example in a 40% of the girl. So hence it is parameter, describes the population. So it's a parameter, or either any variable, or that is anything that describe the variable. So that we are saying the parameter. And then attribute, like that describe in some sort of category, maybe gender will be the male and female, maybe the caste will be there, that caste 2 minute caste, and then religions will be there, maybe the label will be there, label like that high, medium, or maybe we can say low. So this is the thing that we are saying, we are dividing in the terms of class, or either maybe the yes or no, or maybe we can say accept or reject. So it will all comes into the attribute. Okay, so why statistics? So that we have to handle with, just 1 minute. So why we need to do the statistic? We have to handle that all the variability in the measurement. That maybe it comes due to that population itself, within the population, or in the population will be having some sort of variability. So to check the, or either to investigate from that population itself, or maybe we can say we'll say take some sample, and then we'll going to investigate, and then we will going to analyze. Based upon the analysis, we are going to do the conclusion and then interpretation. Based upon that, future roadmap is going to be defined. Future roadmap is going to be defined. Okay, so that statistic can be used in what we can say epidemiology and biostatistics, that effectively collect the fact related to the group of population in places, time, and situation. Biostatistics, they convert all the fact into figure, and then at the end and translate them into the fact, interpreting the significance of the result. So it's more or less it's based upon let's say COVID was there, and if we are doing for the drug manufacturing, so that will, if doing that one, so it will comes under the biostatistics, like it's we are taking the significance effect. And if that's something that we are doing some analysis for some epidemiology, like maybe that 1920 some Ebola virus was there, or now the COVID virus was there, so it's that will comes into that one. So epidemiology and then biostatistic both deal with the fact and figure. As I told, like that any of the study can be done in two ways. That will be the first is the qualitative, and then quantitative. Qualitatively, we can say like by seeing or by representing in a graph term or visual representation. In quantity, we'll say whatever the thing qualitatively we are doing plus in terms of number. For representation, we are going to show the in terms of graph also, in terms of some sort of visuals also, but and additionally we will show that how much changes are there from one phase to second phase or third phase to first phase, or so it's like we are saying in terms of number. So this biostatistic or a statistic itself, it's a quantitative method in that we are dealing about we'll have some time domain analysis. Second is the frequency domain analysis based upon the signal. This thing I am talking about the signal. Frequency domain analysis. If we talk about the some drug manufacturing, we'll have some sort of we'll try to find a mean or a standard deviation, or maybe we can say the effectiveness of the drug. That will be all alone, or maybe we can say if we combining that two types of fertilizer and then or either two types of drug, mixing it up and then we are checking with the investigation. So it's all we have to deal in terms of number. We have to say how much percentage of change we are doing and what is the influence of that change is coming on the output of that. So this is how that in the statistic all works. So use of biostatistic. So it will be the test whether the difference between the two population is real or by chance by the occurrence. That we can check through the that significant test, and then study the correlation between the attribute in the same population. Means we can define or either we can take some decision based upon like how we will going to do the correlation between the attribute in the same population or either in the different population itself. And then to evaluate the efficacy of the vaccine, it's again like some sort of that effectiveness of that, to measure the mortality and then morbidity, and then to evaluate the achievement of the public health program. Something we are making some health program, let's say one example we'll take that mohalla clinic, and will they have let's say 100 setup they have put in any state or either in particular state, and we'll check with that how much number of patients are coming in the daily basis also or either weekly basis, and how many doctors are available with per person that per patient, maybe we can say for 30% one doctors and all these things. So we will check the effectiveness that how much load is coming on the mohalla clinic, or maybe how much the load change is coming in that general hospital or either the AIMS or due to that mohalla clinic, and that effectiveness that will check for the public health program also. So that can be done through that statistic part only. Just because of we are dealing about the public health program, so we'll say it's a biostatistic that analysis we are doing. And then to fix the priority in the public health program, so based upon the severity, let's say we have some 1 minute. Sorry, anyone have asked the question? No. Okay. To fix the priority in the public health program, and then like based upon that, let's say in any district or either any we can say district only, let's say we have a one GH general hospital and some private hospital, and then we have some sort of mohalla clinic or either we can say that dispensary setup. If this a small test setup we are not having, so even that some population will be having mild fever or maybe that light fever, something will be there. So if nothing is available, so they will go directly to the GH hospital. And if someone is having severe case or maybe the emergency case also, they will go for the GH only. So means that rush will be more, and if so that will be like that efficiency of that one particular hospital, that is going to be like going away. For that we have to distribute all the thing, like it should not go on the single hospital or single place. So we have to open some sort of that small dispensary set up or either that clinics, so that it will based upon that requirement of the people it can go. So means first people have to go to that some clinic, based on once it will refer to the GH, then they will go for that some private hospital. So it's like a to fix the priorities in the public health program. Then to help promote health legislation and create the administrative standard for the oral health. It means in that by this method or either we will do the analysis, based upon that we can even the administrative part also we can do. So once we have to do the statistics, so most important part of that we have to collect the data. Data collection can be of any form. Maybe that observation maybe will be there, or either the numericals will be there. Okay, so or maybe that data method of data collection can be a different method. Maybe you can do the surveys, maybe you can take the feedback, maybe you can ask for you are going for taking sample in terms of that population and taking that direct sampling. So in that demographic data comprises details of the population size based upon that demographic and distribution, geographic distribution, ethnic group, socio-economic factor, and then trends over that. It is obtained from census or other public service report. So this data will be already available with the government website. Depending upon the nature of the variable, data is classified into the qualitative data, like it's a attribute and then quality, then discrete data, then continuous, quantitative data through measurement using calipers. Exam will be on 24th March for 8 credit course and then 4 credit course. You can visit the website like for your access, it's already mentioned there. If any change will be there, so that change will be in that announcement section when you are going for the course detail. Okay, so source of the data will be the experiment, survey, records. That experiment, that what we are doing, like performing some sort of investigation research, maybe by the worker or maybe the researcher, maybe the scientist. Survey, that based upon that some sort of disease or community health, based on the taking the data. Records, that is already available with the past record, maybe that government record or something. Based upon that we have to take the data. Once you collect the data, so you have to do the data analysis. So data analysis, so you have to define, okay, what we need to check it out, like which method we need to apply. So that will go start with the binomial distribution. Okay, and binomial distribution, okay, so for that binomial distribution we have the formula for like NCX and then p to the power x, q to the power n minus x. This method usually when we are using that, we know that chances of recurrence or probability is high and number of sample will be less. For the case of, let's say we are tossing a coin, so that probability will be the 50-50. For getting head 0.5, then getting tail also 0.5, and either we can say that we are rolling a dice also. It's like a just we have it in some definite numbers are there. So for that case you can apply the binomial distribution. Okay, and if you say about the binomial distribution, so we can solve some problems also. That I will show you, like if you are going to toss the coin 10 times, so that here will be n is equal to 10, and they will be asking that the probability of getting head at least 7 times. So means probability of getting head 7 times, at least 7 times. So it means maybe the 7, maybe 8, 9 or 10. So what we can so probability of getting head will be 1 by 2, then tail will be 1 by 2. So we'll be having P is equal to 1 by 2, Q is equal to 1 by 2. We can put all this P and Q here, N is equal to 10, X we can just leave it here, X will be X and then 10 minus X. Based on that you can apply, and then you can P is equal to X greater than 7, so you can apply for the P is equal to X is equal to 7, P of X is equal to 8, P of X is equal to 9, P of X is equal to 10. So this is how it will work it out. And sometimes the question will be based upon, let's say I have one PPT I have made. Yeah, cumulative. That one question based upon this, and second question, even though let's say this problem itself we can take. So A and B, this problem I was discussing about. A and B play a game in which their chances of winning are in the ratio of 3:2. Find A chances of winning at least 3 game out of the 5 going to play. So total number will be the 5. Chances of A winning. A win will be 3 by 5. Let's say the P, because that's a 3 is to 5, and then Q will be 2 by 5. Now they are saying chances of winning at least 3 times, 3 games. So P is equal to X greater than 3, 5 CX, and you can apply that formula, 3 to the power 5 by X, 2 to the power of 5, 5 minus X. Now you can summation just write X is equal to 3 to 5, and 3 to the power X, 2 to the power 5 minus X, 5 to the power 5. If you see 5, 5, 3 power x, 5 to the power x, 5 to the power 5 minus x, so x plus x minus x it will go. Now it will not just put x is equal to 3, x is equal to 4, then x is equal to 5, you will get some answer. So this is all about the what you can say binomial distribution. And Poisson distribution, I will say about, like, you have, for that formula we have P of x is equal to e to the power lambda, lambda to the power x into x factorial, and then lambda is equal to actually n into p. Okay, so in the last binomial distribution, if we say about the mean will be the NP, variance will be the NPQ. Here lambda is actually mean, so that will be the formula for the n is equal to p. So where we can apply that number of death from a disease. Let's say you have a 1 crore population, but number of disease will be not that with the close to the 1 crore. It will be maybe the 100, maybe the 1000, maybe the 1 lakh. So it's like, as compared to the population, our chances of occurrence will be the very less. Let's say you have bought 100 item anything, so chances of getting bad or defect product will be 3%, 5%, not like the 50%. In that case, you can apply for the Poisson distribution. So number of death from a disease, not in the form of an epidemic. Again, like, it's not in the case of, let's say we have that virus that's going on, like that went the COVID virus or the 1920 virus. But it's some case of maybe the heart attack or the cancer or the snake bite. So we have a sample or population will be the very high, but their chances of occurrence will be the very low. If you are seeing in a question number of suicide reported in a particular city, so that will be always obvious low. So in that case, you can apply for the Poisson distribution. Then number of defective material in a packing manufactured by a good concern. So again, you will be having pack of 1000, so you will get maybe 10 defective you will get, or maybe you will get somewhere 100 you will get. No, you will not get around 500 or either 800 or either 400. You will get somewhere very low amount until unless there is a failure in the design or either failure in the item itself. Then number of air accident in some unit of time, again it values. Number of printing mistake at each page of the book. So these are some terms like number of telephone calls received at a particular telephone exchange in some unit of time and connection to the wrong number in a telephone exchange. Then number of car passing crossing per minute during the busy hours of a day. Number of fragment received by a surface area from a fragment atom of the bomb. It's like a decay or either nuclear item we can say. Emission of the radioactive alpha particle. So in that particular case, you can apply for the Poisson distribution. Yeah, somewhere it's a Poisson distribution or exponential distribution. If we are saying in terms of time, so you can apply for the Poisson's also or exponential also. Let's say waiting time. So specifically we are going for the exponential time, or if the service time, so we'll go for the exponential time. Even though you can apply for the Poisson's also, you'll be getting the answer same. So this is the one example is there. If will not solve, but I'll just give you the brief. I think this question we have already done in our last session. A car firm has a two car which it fires out by day and by day, like hires. The number of demand for a car each day is distributed as a Poisson variate with the mean of 1.5. So means already lambda they have given 1.5. Calculate the proportion of days in which neither car is used, and second case no demand is published. So if we apply the formula, so we'll be having that P is equal to x e to the power minus lambda to the power x into x factorial. So lambda 1.5 we have, then 1.5 to the power x and then x factorial. Now what is the first question? Proportion of day on which neither car is used. Like in that case, like we don't have anything, so x is equal to 0. So you can, if you put x equal to 0, so 1 power 5 to the power 0, it will be 1, 1 factorial, 0 factorial, it will be 1. So you will get answer this one. Proportion of days on which some demand is refused. When that going to refused, they have that order of what you can say more than 2. They have only 2 car. So if the order is coming 1, so they will going to service the car, or as two order came, so they are going to provide the service. But if the order came more than 2, in that case they have to refuse the demand. So in that case you can apply P of x greater than 2. So in that case you can 1 minus P of x less than or equal to 2. So then you can apply for this, and this is the formula. You can just keep the answer, you will get the answer. Now we'll come to what we can say normal distribution. I will go the second week PPT itself. Okay, so actually that earlier two distribution, actually that binomial and then Poisson was discrete distribution. Discrete distribution. Now that normal distribution will be having a like continuous distribution. Okay, so for that we have the formula for the probability PDF for normal distribution. We'll be having one normal distribution. Second will be having standardized normal distribution. So only thing that we have to replace with that z, that is so for the formula we have 1 by sigma into 2 pi e to the power minus of x minus mu whole square by 2 sigma square. If you put z is equal to x minus sigma by mu, so that will become f of z 1 by root under 2 pi, it will become z square by 2. Z square by 2. Okay. For that mean will be having z x minus, and then so for normal distribution that mean will be x equal to sigma, but here for standardized z is equal to 0, it will start here and then it will go minus 1 minus 2, and here it will minus 1 plus 1 plus 2 plus 3. Okay. So in the standardized, like you will be saying that z value of 0 and not that distribution, it will go minus infinity to plus infinity in that case. So this is some formula for that, and mean is equal to 0, so standard deviation will be the 1, and the area under the curve will be 1. So this is for standardized normal distribution. Here this is a normal distribution, but this one is z is equal to 0, it will be the standardized. So plus 1 plus 2 plus 3, I here plus sigma plus, and then what, whenever we are going to z is equal to plus minus 1, so means minus sigma 1 minus 1 to plus 1, so they will give the values for the 68.3% only. If you go minus 2 to plus 2, they will give 95.4. If you minus 3 sigma to plus 3 sigma, 99.7%. Have you heard about any manufacturing process that is Six Sigma technology? Before that, Three Sigma technology? That concept came from here only. If you take the Three Sigma, so they will going to consider only 99.7% or either Sigma technology. This is all related with the quality aspect, quality control. I'm going a bit off topic, I'll just explain you, and in that manufacturing industry. Okay, so in the sigma, if they will take one, so they, in that case, let's say they have 100 sample. If minus 1 sigma to plus 1 sigma, so they will be taking the sample or 68.3%. So means around 32 or 31% the data is not going to include in the our analysis. So means their efficiency, that whatever data we are going to interpret from that, that will be not that much accurate. So then it came to the three sigma. So in the 3 sigma, 99.7% means almost data is going to be taken part in that. So that efficiency or effectiveness in the 3 sigma, it will be more than whatever the plus minus 1 sigma will be there. And then if we want to get more and more precision, so that 6 sigma technology is there. You will be heard about if you go to the industrial revolution, that you will be come across this that is Six Sigma technology nowadays. Okay, so that's how from here only, from this graph only, they are going to take all in this blue line. They're not going to never meet at this line. They're going to be parallel. It will go till infinity. Somewhere it will 0.00001% it's going to be a somewhere distance will be there. So till now we have Six Sigma technology we have. We'll do some problem that how to see the Z, that what is the probability of obtaining a Z value of at least 1.58. So in that what they have given, Z value they have already given. Okay, is it correct? So now they are saying to find out the probability, means like how much the probability will be there. So in that what we can do, that total of that, just 1 minute. Eight. So here they have already given. So P is equal to probability of Z greater than 1.58. So we know that we don't have to take Z greater than 1.58. So we have to get this value. Okay, total area is equal to 1. Okay, so till here, because of symmetry, this will be 0.5, this will be 0.5. So 0.5 of probability of 0 to Z is equal to 1.58. So this value will get it, 0 to 1.58. So we know the whole area 0.5. We know the whole area 0.5. If we are going to subtract from this, so we will get this area. So that's how we can get it. Probability 0.5 and probability 0.0. 0.5. So for Z is equal to 1.58, how much the value will get? 1.58. If we calculate, so we, yeah. Actually, just say, let's say you have this. This is the thing, Z is equal to 0, this side positive, this side negative. Okay, so total area we know the 1, area under the curve we know 1, and we know the symmetry also. So this negative side will be the 0.5 total area under the curve. This will be the 0.5 area under the curve. Is it correct? So our interest of reason is this one only. Yeah. Even though you can do 1 minus 2 times of, you can go for the minus 1.58 to 2 times of that from here. You can calculate, no, 2 times of 0 to what we can say, 0 to Z 1.58. So means total area from minus 1 to plus 1. So total area we know the 1. If we are going to reduce or either we can say subtract all this area, instead of 0.5 we'll take from here, so it will 2 times of that. So either instead of going for that, because Z value is the greater than 1 that positive side, so we'll take 0.5, then we will calculate from here to here, then we'll subtract it, so we'll get the our interest of reason, this one. Whether got it? So this is about that how we have to calculate it. Second problem is also there, that IQ is normally distributed with the mean of mu. So in that case, instead of here Z they have given, now they have given the mu value and that sigma value they have given. So the person with an IQ of 115 has a high IQ. What is the proportion of the population has high IQ? So means they are saying if a person, if their IQ is that greater than 115, so we will consider as a high IQ. So they are asking for that particular mean of 100 and then sigma 15, what are the proportion or either what is the probability that that population has the high IQ. So sigma is the 100, sigma no, mu is the 100, sigma is the 15. So and then x we have 115, so we will get 1. So now they are saying instead of P of IQ greater than, so not it will become a P of Z greater than 1. So this area will become our interest of reason. Okay. So we can go for the P is equal to 0.5 minus of 0 to 1. Okay. 0 to 1. So 0.5. Can anyone say this value? 0.1 will get somewhere 0.3. 1.3. Don't get confused with that. In that, what was that? 1 minus from like total area I am taking, then subtracting this one. Okay, 1 minus P of Z, whatever the value, so it will be total area from here only. So 0.8413. So for that we have the different table will be there, but the answer will become same. 0.5 minus that is thing, so it will come 0.1587 only. So that's how we in the normal distribution we can see the table. Okay, so now the x is normally distributed and the mean of x is 12 and standard deviation is 4. Find out the probability of the following. So we know the mu value 12, sigma 4, then we'll get Z value, Z is equal to 2, for the value of 20 we'll get Z greater than 2. So now again in the same way we can calculate also here, and then now they are asking for the x less than 20, then that 0 to 12, then find the x. In that case, like they have given the Z value also, Z value 0.24, based upon that we have to find out. Okay, then so this was the all about normal normal distribution. Anyone have the any doubt in this, like normal distribution? This question I'll solve. Okay, so in this question it is actually mean values are given, mu are given 65, okay, and standard deviation like sigma is given 5. So now we'll calculate hall ticket. They will be giving 1 week back. So hopefully by tomorrow or day after tomorrow you will get it. You will get that reminder through mail. No, no, no. By tomorrow or maybe day after tomorrow you will get it. So for the value of, like, their question is the mark obtained by number of students for a certain subject is assumed to be approximately normally distributed with a mean value of 65 and a standard deviation of 5. So this is all about. If 3 students are taken at random from this set, what is the probability that exactly 2 of them will have marks over the 70? So they are like mix of binomial distribution and then normal distribution. From using the normal distribution, we have to find out the probability. Using that probability, we have to find out the exact probability of that by using the binomial distribution. So I will go with that. 70 minus 65 by 5, it will become 1. So Z is equal to 1. For Z is equal to 1, we have the value of 0.8413. Okay. If we go to the table, they are asking for that. If you go from here, so Z is equal to 1. So it will be all population that from minus infinity to till 1. This will not like here. Okay. So this is the thing we got. 0.8413 portion is below of 70 marks. Like 84% of the people are below 70%. So P is equal to 1 minus 0.143. It will become 0.1557. That means 15.57% they are getting that marks above of 70. That's why that's what they are asking for that. They are asking what is the probability that exactly 2 of them will have marks over 70. So means this one P is equal to 0.1557 will be our, the means the probability of getting more than 70 marks is the 0.1557. So we'll have the Q value will be 0.8413. Okay. So now we are going to probability of that 2 of 3 will have over, so that total we have total how much, n is equal to 3, x is equal to 2, p is equal to 0.1557, q is equal to 0.8413. Now we can apply that binomial distribution formula. For getting 2 of them will have marks over 70, so 3C2, P to the power 2 and Q to the power 3 minus 2. Can anyone solve and then can you give the answer? 3C2. Yeah. Now you got it, na? Okay. So so in the starting we need to find the probability from normal distribution, then Z value. So we'll get 0.06 around. Some questions are here. Okay, Vidyasagar, can you tell me? So this is all about the distribution. Then we'll have the sampling. You know that what is the type of samplings are there: purposive sampling, random sampling, then stratified sampling, systematic sampling. Purposive sampling, that sample units are selected with a definite purpose of the view. Random sampling, in that case in which we will take a random from each box, or maybe there will be an equal chance of getting whatever the lot we will be having. Stratified sampling, that we are going to, we will be having too many samples, that is going to divide in a some sort of homogeneous group. It's like we are doing the blocking, or maybe the some other. So it's like we are doing the what you can say, clustering of that. With this, sir, can you please tell what is your doubt? That will be there. That will be there in the system itself. Whatever the value they will provide it. So, and once you are doing the testing, so we have to, very important part will be this, we have to define the hypothesis, that we know the hypothesis when we have done the t-test, f-test and all the things. So, first test itself, based upon that statement, we have to define the hypothesis. That hypothesis, we know that we have the two types. One is that null hypothesis and then alternative hypothesis. So, that a very important aspect of sampling theory is the study of the test of significance, which enable us to decide on the basis of sample result. I mean, like deviation between the observed sample statistic and the hypothetical parameter, like from how much difference is coming, whatever we have taken the hypothetically, and then deviation between the two independent sample statistics. Null hypothesis is the hypothesis that is tested or possibly rejected under the assumption that is true, like what it's most possibly, or the testing that is going to reject it, but the thing, when in the starting itself we are going to assume that is true. Alternative hypothesis, that any hypothesis which is complementary to the null hypothesis, that we are in the null hypothesis, what we are doing, the whatever the rejected one we are taking a true, so alternative will be, that will be the correct, that is not correct. So this is the h1 is equal to mu naught is equal to mu 0, maybe this is the both side tail, two tailed alternative. Then if it is greater than, so it will be the right tailed, less than, so we will be the left tailed. So in when we are doing the significance, so we can do some error also. So in that error we are going to define in a type 1 error. So means we are going to reject the h naught when it is true. Let's say we have assumed that hypothesis is that assumption is true, but we have rejected, but in actual it was true. So that type of error will say type 1 error. Type 2 error, except the h naught when it is wrong. Like type 2 error we can say, like that assumption was taken the true, like assumption is correct, but the thing is that we have accepted, but in actual it was wrong, except the h naught when h1 is true. So it's like just the way of saying that type of error will going to change it out. Then critical result and then level of significance, we can say. We have false positive. False positive and false negative. If you go to that contingency table, you will see that false table, false positive, false true, false positive. You will see that we are calculating the odds ratio and then normality. Okay, so critical region and then level of significance, that is very important actually. Let's say we have this one. So if I'm considering the 1% or at the 5%, it will be like 1 here, 1 here. So for two tail, it will be like that one, that we have one figure also here, this one, two tail test. So this test, so it will be that upper critical region, this is the upper critical, this is the lower critical region, this is the rejection region. If the data is following in this area, so that we are going to reject the area. So what will happen? So this area will say level of significance or critical region, or this full area will say confidence interval. If in the question they are saying the 95% of the confidence interval means 5% of level of significance. If they are saying 99% confidence interval, so 1% of level of significance. So it's this area will say, total area will say confidence interval, or this will say level of significance. So actually this is the importance, that critical region itself is that deciding factor. If that values are getting in between, so we are going to reject the region. It's a rejection region. And then right tail test, so we have to consider the right side. Left tail test, so we have to consider in the left side. So this is the value based upon that for two tail test and the right tail test and then left tail test. So you will get in, if this is the for Z, for T test T value will get, for F test you will get the F value. So what is the procedure? So first we have to define the hypothesis, that is null hypothesis and then alternative hypothesis. Then you have to calculate the statistic. That statistic will be, for T test it will be different, for F test it will be different. Then based upon the level of significance, you will get the value of Z or maybe T value or either F value. If that tabulated values are more, so means that we have to reject the null hypothesis, and then if tabulated are less, so that we are going to accept the null hypothesis. Then we are going to make the conclusion. So for T we have, this is that statistic value. This will discuss, we have third week, we'll go with that. So now we'll say the T test. Actually, if you say about the T test, so that usually used for the less number of sample. Okay. So condition, the population is infinite and normal. The sample size should be the small, and population variance will be the known, and alternative hypothesis may be one-sided or either it can be the both side also. So for that we have the formula. So first we have to to test the mean of the random sample. So we have to go with the set the hypothesis, that first we are going to assume that mean, both of the mean are same. Okay. Then alternative will be that that is not same. Not same means that will be two tail. If it is greater than, so it will be right tail test. If less than, so it will be the left tail test. So for this to test the mean of the random sample, we have the test statistic T is equal to x minus mu by sigma x. So T, or if we calculate the x minus mu, x bar minus mu by s by root n, so that you will get a T value. So this is the T calculated. Now you will get, for a degree of freedom of, let's say you have a number of sample 30, so you will get a degree of freedom n minus 1. So for that degree of freedom you will get a value of T tabulated for level of significance and then degree of freedom. Okay. So now you have the T calculated and then T tabulated for a given level of significance. So if the calculated T greater than tabulated T, so reject the null hypothesis. If calculated T less than of tabulated T, so we are going to accept the hypothesis, means there is no significance difference are there. So that is the one question is there, that 10 individuals are chosen at random from a population of, and their height are found to be inches 63, 63, 64, 66, 69, 70, 71, like we have the 10 samples are there, and the mean they have given 65. So first set the null hypothesis, that will mu is equal to 65. They are asking to discuss the proposal that the mean height of the universe is 65. So they are not saying greater than 65 or less than 65. They are asking whether it is 65 or not. So means musical that first we are going to assumption that is the mean height is 65 inch, and then alternative will be the mean height is not 65. So means that not equal to 65. So it will means the two tail test. So now we can calculate the that x bar, then sample standard deviation. That standard deviation formula we have root in the summation of x minus x bar by n minus 1. You will get 3.16. Then you can calculate the T calculated. You will get some value. Then degree of freedom n minus 1. Now you can see that T calculate or T tabulated is more than that of T calculated. Like T tabulated is more than T calculated. So we have to accept the null hypothesis. Means mean height of the universe is the 65 inch. So this is how. So you have to know that, like okay, the mean they are given. So you have to use this formula. You have to use this formula. Okay, and then you have to apply, and then you have to conclude it. Again we have one more question is there. Instead of they're like giving that a sample size or sample, they have given already x bar, mu, and then standard deviation. You can directly apply the formula. The shop manufacturing company distribute a particular type of brand through a large number of retail shops before healthy advertising campaign, and the mean sales per week per shop was 140 dozen. Okay, so this is before the advertisement. After the campaign, sample of 26 shop, so n is equal to 26 was taken. Mean sale were found to be 147. Instead of first it was 140, it became 147. So now they are saying with the standard deviation of 16, can we consider that advertisement is effective or not? So first we are going to say mu is equal to 140 dozen, means there will be a advertisement is not effective. Now they are saying advertisement is effective. It means effective once when it will become effective, that average mean or mean should become greater than of 140 that already existing. If it is coming less than of what existing, means in that case that is not it's not effective. So they're asking for the effective. So it should be a greater than of. So it's mean right tail test. Now you can get that degree of freedom n minus 1, then you will get a 25, then you can calculate that t value, t calculated, you will get some value 2.22, and for here it's not mentioned. So if it is not mentioned in the question that level of significance, you can take the 5% level of significance. For 5% level of significance, t tabulated, you will get 1.708. Everyone knows that how to see the table, no? Or shall I show the table? Shall I show you, or either all are able to see the table by your own? Just say here is table already open. So degree of freedom here is there. Let's say for degree of freedom we have to 25 was there, 25. For two tail 5%, 10% of level of significance, 5%, 2%, and 1%. Now we are going for the one tail test, that is for 5% level of significance and 25. So it comes 1.708. You can see. So that's how degree of freedom you can go through that two tail test. You have to know that which test you are going for, that two tests. So this is for 10%, this is for 5%. So if it was 2% test, degree of freedom 5 here, so it will become 5% level of significance, the value 2.060. But for that particular question, we were having one tail test with 5% level of significance for 25 degree of freedom number 1.708. Is it correct? So you can see by this way only. This is for T test. For Z test, that cumulative one, for that from here, so you will get like this. And for one more table we were having, Z test. Okay. Yeah, I was having, and I have different tables also. Like that depends upon our convenient we can use. What? Yeah, if you want, then I'll can put this PDF there. This PDF. Okay, I'll keep it. There's no issue with that. I can keep it. So that's how you can see. If you are feeling difficulty, again you can just see, like it's just you have to apply some sort of that logic to seeing the table. There is nothing is there. You will be, yeah. The decision is there only, that we have to stuck it out there. Like we have to stress. Okay, which one we have to go for that based upon that statement they have given the question. Okay, so now the second type test is there. So in the T type test, we have the four type of testing will be there. Earlier it was the mean of the sample. Now difference mean of the two sample. Earlier, the single population was there. From that, we were taking the mean sample. Now we'll be having two samples, two population will be there. From that, we are going to draw on a two mean and to test the significance of the difference mean of the two sample. So again, earlier it was we were having already mu was there, but now mu1 is equal to mu2. So that set the hypothesis first step. That one assumption will be there for both of the populations. Sigma 1 is sigma 1, or either means standard deviation will be the same, means variance will be the same. So first we are going to decide the hypothesis, that mu1 is equal to mu1 is equal to mu2. Sorry for that. Okay, and then alternate hypothesis will be either it will be not equal to, that will be a two-tailed test. If it is that greater than or equal to, it will be a single test. So for that we have the formula for test statistic. Again, this formula will be the same because x minus mu by sigma x. Then here formula will change for the x sigma x value. So sigma x. So that will be s by root under n, or s just because we have two samples here. So 1 by n plus 1 and 1 by n2. So for overall formula will be having s is equal to root under, that is the formula of standard deviations only. Root under sigma x1 minus x bar is whole square plus sigma x2 minus x bar whole square by n1 plus n2 minus 1 minus 2. Earlier it was n minus 2 because only one sample was there, but now it will become 2 because we have the two samples are there. If we'll say draw from the 3, n1 plus n2 plus n3 minus 3, we can, that's how we'll go. Okay, so then decision will be the same for given degree of freedom and level of significance. You will calculate the t tabulated. From here we will get t calculated, t tabulated. Then you have to decide whether that our hypothesis is correct or wrong. Either we have to accept the null hypothesis, or either we have to reject the null hypothesis. So again we have one question. So instead of that, there earlier it was only one sample was there, now it will come to two sample. I will not explain it because it's already there. You can see the video last now. I'll go ahead. So that's how you can get it, and then you will calculate the t calculated, then t tabulated, and then you are going to, based upon that, you are going to accept the null hypothesis or either reject the null hypothesis. Now the third case for the t-test we are having to test the significance of the difference between the mean of two sample, dependent sample, it will be the paired one. We'll do that unpaired also, that is independent also. Now for the dependent sample we have. So null hypothesis, that will be the mean will be the same. That alternative will be that either two tail or either one tail. Then again degree of freedom will be the just because of that was a dependent sample, so it will be always both sample size will be the same. Just see, in the earlier it was n1 can be 10, n2 can be 12 or 13 also, but in the case of dependent it will be same. So n1 n2. So in that case you have to apply with the n1 n minus 1 only. The degree of freedom will be the n minus 1 only. Then the statistic formula will be having d bar by s by root n, and then s we can calculate the d minus d bar by whole square, d we can get the increment value. So then again once you calculate with the t, so you can calculate the t calculated and then t tabulated with the table, and then with the formula you can take the decision. Let's say we have a formula. That test actually you are using whenever we have to check the efficacy before and after training, also before and after drug administration also. So that's how you can check with that. So here an IQ test was administered to the 5 people before and after, and then they are asking whether any changes IQ after training it is there or not. So first we have to calculate the D. So that that can be positive, that can be negative also. First you have to start with the hypothesis. This is a null hypothesis. Just see, they are saying test, yeah. Yeah, before and after. That way you can do anyway. Just see here, it's a square. anyway it will come positive only. Yeah, it will be positive only, it will come. Now the thing, just see the tone of the question is that test whether there is any change. They are not saying if change is greater or change and change in the less. In that case, you have to use the single tail. But here they are saying any change, means maybe that they have to use the two tail test. So by seeing the last line of either the line of the question, you can decide itself which test we have to go for that. Okay. So here we have to use the two tail test. First we have to x1, x2, then based upon that we will calculate the d, x1 minus x2, then d minus d bar, then d minus d bar ka whole square, then we will calculate the s, then we will put this value into d bar by s root n, we will get the t value, and that will get negative, no issue with that, but we can take the mode, and then we will get the value of t calculated. Based upon that we are going to decide, okay, we have to accept the hypothesis or either reject the null hypothesis. So you can make the short notes for that. You can collect all the formula at one place before going for the exam, like for this type of test, different type of test. Just 1 minute. हेलो अभी 4:45 तक लेक्चर खत्म करते हैं तो आते हैं. हाँ वो अभी तो लेक्चर ले ही रहे हैं. कितना हुआ? 4:15 हुआ. अभी 1.25 घंटा ही हुआ है. कम से कम आधा घंटा और ले लेते हैं. चल ठीक है, 4:45 तक आ जाना. तू है, हम लोग जा रहे हैं. हाँ तुम लोग पहुँचो, मैं आता हूँ. 4:30 भी करते हैं. ठीक. Okay, sorry for that. Okay, so this one question was there. Now again one problem is there, the same level only. Now they are saying, can it be concluded that stimulus in general be accompanied by increase? Means right tail test only, or either one tail test, because in both case the value will be same only. Now to test the significance of an observed sample correlation coefficient, so that test statistic, this formula you can use. So you can collect all the test at one place. You use the formula before going. You can just revise it, and then you can see which one you have to apply at that particular moment of time. So for this test statistic, we have r by root under 1 minus r square into n minus 2, and then degree of freedom will be the n minus 2 for this case. We have one question that we have done already. So here they have given n to 27, and then the correlation coefficient they have given 0.42. If the question will be sometime tough, so they will ask to calculate the r also, that we have done regression analysis problem also. Usually they will give the direct formula, direct value they will give, so there is no issue with that. So again they are saying if that variable in the population is the correlated or uncorrelated, so then we can apply this one, and we can get the value for the t tabulated with the 0.05 significant. Then that's all about the t test. Now we have the f test. In the f test, why we are using the f test? Anyone have the idea? Like I have already discussed. To check the variances, earlier it was the mean and all this thing. We were assuming that in that mean the variance is same, but now we have to analyze the variance itself. Okay. In that case, one test statistic formula I have shown, I think, in the second week of PQ. Yeah, PQ something that sometimes will come here. You can just say you can like until and unless it's given already that variances are same, so you can directly apply. There is no issue with that. If they are saying okay, two different proportions are there, so in that you can P1 Q1 by N1 plus P2 Q2 by N2. So they will be obviously mentioning that their different variants are not same. So in that case, you can apply this formula. Mm-hmm. Mm-hmm. That n minus 1 for the 1, and then that will be the second will be the n minus, again n1 minus 1, and then n2 minus 1. I think that case separately. Yeah, separately we have to do. For that case, they will be giving the values, or I think that type of question will be not asked in the exam. If you are going with that, then you can follow some SOM series book is there. In that they have detailedly explained. So we were at the F test, so we have to check with the variance. That is same case. We have to define the objective is that we have to take the significance of the equality between the two population variance. Yeah, okay. Uh-huh. N minus 2. Yeah. When we are talking about the sample correlations, so we'll be having already two types of data will be there already. When we are talking about the correlation, so that correlation we can't take at a single sample or single population. Understood? Correlation will be coming if it is 2, 3. We can correlate one person to another person. That we can't correlate single person itself, na? Is it making the logic, na? So in that case, so for that case, when we're talking the cohesion, so we are taking the degree of freedom will be the 2, because that is they have at least two sample population will be there, two sample or two population will be there at least. So means we are going for the n minus 2. So means correlation terms is coming. So we have a two group of people or two group of sample will be there. So it's a two already there. So we can take at least two. Yeah. Correlation. Yeah. Yeah. No. Just say our correlation coefficient will be the always 0 to 1. Degree of freedom can be anything. That depends upon the number of sample. Uh-huh. Yeah. So it's actually t value getting us. So t can be a 0 to 1, that can be 0 to anything. Maybe that's up to whatever the table that is existing. If we are saying the correlation coefficient, that will be always 0 to 1. When that case will be 0 to when that case will be the 0, r is equal to 0 means not a single data that is correlated. It's all different type. If let's say this one, if we are saying about r is equal to 0.5, so 50% of the data they're going to add somewhere close like this. If r is equal to 1, so it's all like this only. So this is different. Degree of freedom is different. So F test. So we have the here formula. This is the T test only. So in the same here also we have to start with the hypothesis. Then we can go for that alternate hypothesis. Same way. For that formula we have f is equal to s1 square by s2 square. It will be always s2 square by s1 square also. But the thing is that will be always greater than 1. Maybe the greater variance by the smaller variance. That in general will say. For here, degree of freedom will be the n1 minus 1, or degree of freedom for second will be the n2 minus 2. For two degree of freedom, we can get the f calculated, and then f tabulated will get from the table, and then we can get the value. So here we have a test group of people. Two normal populations are there. Group A, some different numbers are there. Group B. So examine at the 5% of level of significance. whether the population had the same variance or not. Okay, so means they are not asking for that whether that one group is getting more, one group is getting less. It's saying whether, okay, they are asking for just to check the same variance or not. So we have to start with the null hypothesis. It will be, we'll assume it's the same variance. Then we'll go for the alternate hypothesis. It's a two-tailed test. Now we'll calculate for the group A. We'll calculate the S1 square. Then second we'll calculate the S2 square. Now we are going to calculate the F calculator, S1 square by S2 square. You will get a 2.2, and then for we have this n minus 1 and then n2 minus 2 n2 minus 1, then here alpha by 2 total test. So you will get a 5.6. So again you have to accept the hypothesis or either reject the null hypothesis. Then here directly it's given. So this was the all about the third week. In the fourth week, what we have actually, we have to go with the ANOVA. Why do we need to go for the ANOVA? Anyone? Variance comparison, and it's like in F test we are also doing the same variance. Yeah. So it's like in that we are very limited about the variables, but here we'll be having multiple variants. Multiple variable can be there. So which, yeah. Okay. Three-way ANOVA. That again I will see, and maybe I'll put the material, because even though I didn't went, I have seen the lecture, and but I didn't see any question from the three-way of ANOVA actually till now. Okay. Okay, fine. If it is there, then I'll upload some materials. If you can just note down, and then in the last of today's lecture, just see me that what you want to put in that drive folder. I'll keep all the things. So ANOVA we have to do for like analysis of the variance actually. In that, let's say we have a academic department is there. In that we have the lowest average grades will be explanatory variable, response variable. So in that two variables will be there based upon the same things, but we have to define it in a different way. Then after which kind of promotional campaign leads to the greatest store income at the Christmas time. Then will be the promotion time. Then daily store income. So it's a, how do we type of the career and marital status of the person related to the total cost of the annual income she is likely to be make on her health insurance. For that particular, we can apply for the ANOVA test. So in that explanatory variable, it's the career and the marital status. Response variable will be the health insurance payout. So it will be changed within itself. Hypothesis of the ANOVA, these are always the same, like H naught, that is the null hypothesis. The population means of all groups under the consideration are equals. Second will be the alternative hypothesis, means it's just a complementary of null hypothesis. We have one more example, like a car magazine wishes to compare the average petrol consumption and three similar metals of that available 6 vehicle of each model. So in that they will check for the model 1, model 2, model 3. Then we have the car of 6 model we have. So now they are asking for that, okay, how that significance of that average that affecting. So means 3 model are available. So there is a 3 independent sample, each of 6 size. This example is extension of earlier test, that is F test, which was for the normal population, means using independent sample and pooled estimate of the variance. It's a one-way ANOVA, means a one-factor analysis. Then again they are saying that teacher is interested in a comparison of the average percentage of the marks attended in the examination of a 5 different subject. It's like they are asking for the in a class percentage of the marks attended in the examination for different 5 subject for a 8 student. Maybe the student can be anything, 5, 8, 10, 15 for the whole class also. So it's like a 5 examination. There are 5 dependent sample of each extension of price. It's that we have to apply for the two-way ANOVA. So means we have 5 different subject also, and then some 8 students are there. Assumptions of the ANOVA. It's like the subjects are chosen via the random sample. Within each group, that data will be the normally distributed for all. while the population means may be different from the one group to next, the population standard deviation will be the population mean can be different, but their standard deviation will be the always same. This is the some sort of that normality test we are saying. Okay, so this is not that much robust as compared to like otherwise somewhat robust as compared to the other method like maybe the t test or either the f test. Okay, so that formula we have start with the hypothesis, that is the h naught mu1 is equal to mu2, mu1 is not equal to 2. Then we can calculate ANOVA statistic, that summation of Ti sigma x square js. You have to calculate the SST, then SSB, then you have to calculate this is the between, sum of a square of the between, sum of the square of the within. Then we have a ANOVA table. Sum of the square, degree of freedom, means of a square, SSB, SSW, error, and then variance ratio. The variance ratio will be the MSB by mean square of error. Mean square of error, how we will get it? SSB by degree of freedom, SSW by degree of freedom. Then it will become a F calculated. Then again, once you done with ANOVA table, you will calculate the F calculated. Then you will from the table you will calculate the tabulated. Then once you calculate the F calculated and F table, you will get to know that decision we have to check. So this was some examples was there. One way ANOVA, and then in the last we have two way ANOVAs also. I will show you. In the two way ANOVA, we will be having the without replication, with replication and interaction also. But usually we'll go here with that without replication. That interaction coefficient we have discussed in design of experiment, that how we have the three variable. See, so this is that main effect will be there. If you calculate the AB, so that interaction effect between the 1 and 2, like 2 only. Now if we ABC, so it will be interaction effect between the 1, 2, 3, means for all of 3. So for that now we have to calculate the two way ANOVA. That is one calculation we have to do, SST, SSBR between the row, between the column. Then we have to make the ANOVA table. Then between the row, between the column. Then again in the same way we have to calculate with the MSB by MSE. Here the error, but there it was degree of freedom. So for two way ANOVA it is different. So from that you will get a F value, and from for degree of freedom and then level of significance you will get a calculated table value, not tabulated value. Then you can make the decision. So we were having this question, the 4 farmers they are using the different manure, and that from that you can use like 4 type of manures. 4 farmers they are using different types of manure, and then different farmers they are using like this. So you will calculate xj, xi, x square, xj square. You will calculate the SST, SSB, SSR, then error. Error will be the SST minus SSB and SSBC. SSBs are row and SSB column. You will get some value. Now from the ANOVA table you can get the FR between and then FRC. Then you can calculate the F value. Now this is the one question. Interaction effect was there. I have already explained that ABC and then that three-way factor, or either 3, 4, 5, 6, that can be anything. So these are all about the ANOVA. Now we will go with next week we were having the normality test. I think we'll go a bit fast. Test for the normality, like we have to check with the data coming for the normality distributed or not. What will happen? What we are assuming that with that data are normally distributed, but the thing is that we have to check with that. Okay, whether the data are normal or not. Let's say we have some group of data, say 100 or 150 are there. We'll say directly, okay, assuming that data are normal, but sometimes if the data are not normal, so result will come very odd way. So for that we have to do some sort of test. That is ways. Yeah, obviously we can differentiate. If that they are not pass, yeah. If they are not pass, yeah. If they are not passing the test, so we have to go for the non-parametric test. If the test passes, so you have to go for the parametric test. Is it Okay. Okay. So then null hypothesis, that data comes from the normally distributed population. The test result indicate whether one should reject or fail to reject the null hypothesis. Then we have to go with based upon the null hypothesis only. So if the variable is normally distributed, you can use the parametric test that are based on this assumption. If a variable fails to normality test, so it is critical to look the histogram or normal probability plot to see if any outliers are there or not. Count the non-normality. That the Wilcox sum test is there. In that we can see the outlier. We have the first quartile, second quartile, third quartile, fourth quartile. If that all quartile the data is coming somewhere outside, so we'll say outlier. We have to check whether that outlier is causing the non-normality or anything. So from that we can just transform in the form of some log and a square root. You can see, like, if that variabilities are not too much or non-normality are not too much, so we can just transform the same data to in terms of some logarithmic or either the square root. So then once you transform the data, so it maybe data will become a normal. So if data becomes normal, so you can use the parametric test. So that will be the ANOVA and all the things you can use, maybe the t-test and all the thing. If we are not able to do, the transformation is not viable alternative, so then we have to use the non-parametric test. Okay. Types of normality test, that is Shapiro-Wilk-W test. This is a test for the normality has been found to be the most powerful test in the most situation. It is the ratio of the two estimate of the variance of the normal distribution based upon the random sample of n observation, and the numerator is the proportional to the square of the best linear estimator standard deviation. The denominator will be is the sum of a square of the observation about the sample mean. It's it is the ratio of it is the ratio of two estimates of the variance of the normal distribution based on the normal distribution of n observation. Numerator will be a square of the best linear estimation, maybe that normalization we can say, and then denominator will be the sum of the square of the observation. Means it will be the total and then best estimator. Second one is the Anderson-Darling test. This test actually developed by the Anderson and Darling is a ADF, that empirical cumulative distribution. It's like we have the data will be the n terms, maybe the 100 or something will be there. If 1 by n terms, it's just by like we are doing the 1 by terms, so it will become the empirical terms. So in some situation, it is found that the powerful as the Shapiro-Wilk test, and this test is not calculated when a frequency variables are specified. It's just I'm saying what are the tests that is available for that normal test. Usually we don't have to do with hands. You can apply any of the computational method, maybe the Origin, maybe the Excel or any other SPSS software or anything. You can apply it and then you can get that okay data the normality, or even you can get some websites are there for the checking the normality data or so it's just giving the brief that you have all the resources available all out of there, but the thing is that we have to know that which test when we have to apply. That is very important. That's why we have to get to know that which are the tests already available, when we have to apply the which test. So that is a very important. Then we have a Martinez-Lewis test, and if we say about the Kolmogorov Simon test, this test usually used in the biostatistics. Even I am working in the biomechanics, so this test usually I am using for the testing for my data. That we have some participants that we are taking data for the EMG data, and we'll do. Once we'll do the normality test for this that Kolmogorov test, and then I'll go ahead with that our own analysis. Actually, this is the best for the biological application or either biostatistic problem. Then we have another type of test like Ryan-Jones test is there. Then we have the D'Agostino-Cortese test is there. Then Skewness test are there. Okay. So there are some things that I have already kept in the things like when we have to apply which test. You can go through that. Then we have one more things that odds ratio parametric test that we have. That way to check for the normality, independent t-test, dependent variable by the group, pair t-test, pair difference, one-way ANOVA residuals, it's error, repeated measure residual at each in point. Pearsall correlation coefficient, it's both variable are normally distributed, and then simple linear regression, it's again checking with the residual. Okay. You have all the idea about the skewness and then cortices also now. Skewness, we are just asking the shifting in the right side or left side. If we are saying in that negatively skewed, they are shifting in the negative direction. Normal means no skewness. Positively skewed, it's positive direction, it will get skewed. Means mean is going to down positive side, mean is going to get the negative side. Skewness formula, that's actually a third moment. If you are binomial, or maybe we can say that Poisson, or for all we can get the that first moment will be the mean, second moment will get the variance, that variance, then third we are getting the skewness, and then fourth moment we have the cortices. So there's a big formulas are there for that. You can if it is required, otherwise you can we can get the directly answer for this skewness and then that cortices from the direct application based software only. Then cortices is the statistical number that tell us if a distribution is taller or shorter than the normal. Let's say this is our normal distribution. So cortices is going to define whether it is or this one. So this is our normal. This will be like what you can say, platycortic and then leptocortic. So let's say we sharply peaked with the fat tails and less variable. Mesocortic, medium tails, and then platycortic, the fat tails. So it's a cortices will be the less means platycortic. If cortices is equal to 0, it's a normal distribution. Leptocortic, it will be like greater than of whatever we have. So it's a fourth moment. It was the third moment here. This one is the fourth moment. Even we can get the skewness and simple cortices for this following group of data also. We have done already for that also. Now we'll come with the odds ratio. Odds ratio, like again we have to check with that for relative to the relative measure of the risk, continuous variable, and then response progress. Odds ratio is the one of range of a statistic used to assess the risk of particular outcome if a certain factor is already present. The odds ratio is a relative measure of the risk, telling us how much more likely it is that someone who is exposed to factor under study will develop the outcome as compared to the someone who is not exposed. It's like a someone who already affected, there some value will be there. It's not affect, like it's not exposed to. So in that case, we'll get some sort of that odd ratio. Odd of an event of happening is the probability that the event will happen divided by the probability that the event will not happen, means directly, like this. Odds will be probability of an event happening P1, probability of an event not happening. It's a individual, it's a single. Odds ratio, it's like we have the odds ratio is a measure of the effect size describing the strength of association, non-independence between the two binary data. It's like for one case, and second case we'll check with that. If the probability of the event happening in the each group P1, P2, then odds ratio will be the like this, P1 by 1 minus P1, P2 by 1 minus P2. So we can get that relative risk also. If we have that group 1, group 2, number of times event happened, number of times event did not happen, odds ratio will be that. What will be that? Number of event that A by B for one group, A by B. For this one will be C by D. Then now we can simplify, we'll get AD by BC. For R, that A relative risk, we can calculate the A in terms of A plus C. That number of events is happening, not even that's A plus B. Okay, sorry. Then C by C plus D. So this is the relative in one group itself. So that we can have the one formula was there already there that we can calculate. Then chi-square distribution actually for the fitting, it's like a non that parametric test only. That continuous distribution is symmetric and depends upon the degree of freedom. It is used to construct confidence interval for the variance, to compare set of accurate frequency with the expected frequency, that test how well a sample fitted theoretical distribution of the good data. It's like a fitness of the test. Okay. So that area under the curve will be the always 1, and the area under the area under the curve between the 0 and then chi-square value is the cumulative property. Just 1 minute. Hello sir. Hello.
Can you keep these things ready? Our technical fix document.
Okay sir, that I have already sent that is fine. Mail is fine.
Mail is fine, I think. Maybe you take a printout and come. We will keep that also. No problem.
Maybe we'll see sir tomorrow sir. Now I'm taking the lecture now. So
No. Tomorrow morning. Tomorrow morning around maybe 8:30 can you bring? 8:30 I have class.
after that only sir, maybe 9:30 or maybe.
Okay, 9:30 you bring.
Okay sir. Model paper we are not having actually. Actually, usually NPTEL will not release for that, so I'm not sure. You can ask in that discussion forum. Okay, so in the again chi-square test we have to do with the different like chi-square test is observe how far the object counts are expected count. The formula used for the statistic is summation of observed minus expected square by expected. The condition will be always that same will be there because data will be that no information about the parent population. No expected frequency should be the less than 5, and then the total frequency should be the large like n greater than 50. Means their summation of expected or observed it will should be same. Okay. So parametric or non-parametric test like so we have to set the hypothesis, that is null hypothesis alternative. Then test statistic will we have to use this formula. We'll get the degree of freedom nu, that will be the based upon the data we'll see, and then conclusion we can make. Chi-square test for the dependence of the attribute. So we have that independence of the attribute. We have two A, B, C, D's are there. Column, rows. You have this formula. You can get the expected value. Observed value we will be knowing already. Expected value will get calculated from the A plus B. For this one A plus B and B plus D. A plus B, A plus B, and then B plus D. With this, no, for A, what will be that? A plus B, and then A plus C by total number n. For expected of B, for B case, A plus B, then B plus D by n. For C case, C plus D by A plus into A plus C by n. For D case, C plus D plus B plus D into n. And then if you print that one, you can keep this here. You will get the chi-square value. From the chi-square table, we can get the answer. So we have one that certain area that quinine was administered at 812 people with the total population of 3248. The number of liver cases shown in the below. Discuss the usefulness of the quinine checking the malaria. So we have this one. So now expected value of the this one 20 you can get, expected value of 792 you can get, 220 can get. So this is that observed value we have. This is the EO for that one. This is the FO means observed frequency. FE for expected frequency of the 20 it will get like this. So they can get and then we can calculate that one. Then again we have one more example. Then second test will be having chi-square test for the goodness of the fit for the uniform distribution. Uniform distribution will be total frequency by the number of sample. Okay. The same way observed frequency here, total frequencies are here. It will be observed frequency, uniform frequency will be all same. Now you can apply the same formula. You will get the f that chi-square value. Now chi-square test for the goodness of the fit for the binomial distribution. So we have to use the binomial distribution formula for each and every value that will be have expected value will be get number into whatever that probability will be getting from here. Let's say we have this example. So that h1 p by q and then not equal then p of x. So we'll get this one. Now we can multiply with the n into px. So we'll get of expected frequency at x is equal to 0, means there will be no boys will be there, all girls will be there. In that case, you will get some value for x is equal to 1, 2, 3, 4. You will get some sort of here. Then FO we know already. For x equal to 0, for FO we know already. Now we have calculated from this. Now we'll calculate FO minus FE, FO minus FE square. Then we'll calculate chi square. Then summation of that, we will get the value. The same thing can be done for the Poisson distributions also. Okay, so this is all about the chi-square test. Now we'll see the hypergeometric. In the week 6 we were having exponential distribution, then hypergeometric. Hypergeometric, that we are having some sort of that we are like multiple boxes are there. We are taking some sort of choosing that sample from the box, and then based upon that we are okay. We have to calculate the probability of that one. For exponential terms, that will comes the time for the waiting, time for the services. So you can apply that formula, you can use it, and this was all about like exponential distribution formula was we are having lambda e to the power minus lambda x, and that will change with that when the lambda is increasing. Mean will be that 1 by lambda, variance will be the 1 by lambda square, standard deviation will be the 1 by lambda. We are having the one example was there, and beta and hypergeometric. Then in the 8th week, no, in the 7th week it was all about the design of experiment. Why do we need to do the design of experiment, and what is the advantage of the design of experiment? Actually, what are the approaches for the design experiment? Actually, approach for the experiment with the heat and trial method. Maybe some different methods are there. Approximation method will be there. Design of experiment will be there. So among of all that, design of experiment is more convenient because we know the output also, input also, that we can vary with that, and we can plan it, and then we can see the number of experiment also. Okay, so in that some terms was there. Wide DOE, so it will going to reduce the time to design and develop new products and processes, improve the performance of the existing processes, improve the reliability and then performance of the product, then achieve it. And key terminology will be there, that interaction will be there, randomization will be there, blocking is there, replications are there. I told what is the interaction and then randomization, blocking I have discussed already. So interaction some factor does not have the same way. But if the lines are parallel, so it means there is no interaction. If they are going to cut at some points, it means that there is some interactions are there. Then randomization, it's like to remove the biases. If we have the box, we don't know, we have mixed it up, some balls are there, 4 blue, 4 3, that will calculate directly. If we are going to show, we'll have the box, that is we know that it's there, so we'll take, sometimes the bias will come. Let's say we have one tables are there, 4 white ball, 5 black ball, some balls are there. So you will see based upon the color you are going to take it. But if you have the box that is fully packed and you have mixed all the balls, 20 balls are there, so there is a bias that you can minimize it actually. Blocking is like we are doing the clustering. We are homogeneous in the all type of heterogeneous data. We are taking the same set of label or group of data we'll take at one place, and then we are going to forward with that. Then it's like we are grouping at one place. Like female case, we are keeping all the data for the male at one place, for the all female data at one place, and then we'll go ahead with that. Replication with that we are going to same configuration of the experiment, we are going to repeat it, so that we are going to remove that, minimize the error, or we are checking that whether there is a noise is there or not. Then we have seen about the types of the DOE, 1 factorial, full factorial, and then fractional factorial. Then we have that first order design also, second order design also, and then regression also. So in the 1 factorial, it's like 1 factor was there, so it's simply will take, and then will simple factor will take directly. Then full factorial, what will be that, we will be taking it in terms of 2 to the power k, that number of factor. Fractional factorial, 1 by 2, 1 by 4, 1 by 8. Then we have the whatever the factors are there, based upon that we are going to see. So multiply of 1 by 8 times they are saying, so do minus k minus p, it will something 1 by 8 into, let's say, 1 minus 3, because this was 3. So 1 by 8, 2 to the power 4. So 1 by 8 into 16. 1 by 1 by 8, so it will going to multiply with that only. So this is somehow it will become, number of experiment will become 128. So this is how fractional, why we are doing fractional, we are doing to remove the repetition. Full factorial, we are taking each and every factor, will do the experiment like this only. Let's say you have a 10 factor, so you are going to do the experiment in 2 into 2 into 2 into whatever comes, it will the 10, 1, 5, 6 you have to, times you have to do. Okay, but in that fractional, we are going to remove 10 minus 7, so it become 2.3. So we'll do the 8 number of experiment only. It's like a, what you know, whenever we will be having interaction, number of interactions are more, so in that case the effective or that influence of that higher number of interaction, it will be always less. So we have to came across that interaction or either that value, they are not going to influence too much on the response. So for that case, we'll do the fractional design. We have the screening also. In the screening is a similar of that, we are removing what we can say, that unwanted, the factor that is not influencing too much. And then response surface analysis itself, it's coming in this only, first order, second order design only. It's like a y is equal to a plus bx. Then second order will be the y is equal to a plus b x square plus c x plus d. It will be like this. Regression will be the fitting of the line. We have to find out the slope, intercept, r square value, r square adjusted. That all we have to find out all these things. So this I will not explain too much. It's you can go through that. If anything doubt is there, you can ask. As of now, like full course, anywhere doubt is there, please ask. Huh? Which one? Which one? Which one? Which one? That resolution, the say 3, 4, 5, 6. That depends upon the nature of the experiment you have. I'm saying. No, I'm not saying about the 6 and 7, or I'll not say about the 10 also. Let's say you have a, it's, the thing is that now you, let's say you have one experiments are there, in that you have a 10 factors are there. In that 10 factor, only 6 are there, so based upon the nature of the experiment, you'll be going with the 6 only. But if some, for other people, I have shown one table actually in the 8th week. Here. This one, number of factor, then fraction, then resolution also. So based upon that, you have to see which one is. Let's say I have taken fraction of the 2 to the power n minus 3. The 10 was there. 64 number of runs we have to do for this particular case. But once we have went for this, so their interaction is very very low. So what we are not going to take for that also. Again we have done for that. So what we'll do for, then 9 minus 4 we'll check with that. So you have to first calculate. So it's a more or less you have to do the hit and trial. Then based upon that you have to come up with the optimum number of experiment. Just see, if you are running the experiment, so what will happen, the times and resources are going on. But the thing is that before starting the experiment, we have to very specific that for how much numbers we have to go for that, which resolution we have to go for, the 3 resolution or either the 4 resolution or either the 5 resolution. Okay. Uh-huh. Uh-huh. Which one, where? It will, if you do like this, somewhere it I have seen, this one, now you have to multiply this one just a summation of this multiplication. So if we calculate the 0 0, so maybe 0, this is also 0, but their multiplication, it will come somewhere, some point will come. Understood? The formula summation of multiplication of this one, x minus x bar, y minus y bar, not the summation of this one alone and alone. It's not the alone and alone we're taking. It's a summation of this multiplication. This multiplication. So first you have to multiply with the 2.7 into 0, 0. 5.7 into 5, some terms will come. 9.2 into 9, some will come. You have to take summation of these, then put here. Here. Just if for the population, it will be the n. If you are taking the sample, it will be the n minus 1. This thing I was having also a bit, so that's why I taking bit clarity. That's why. Okay, then we'll wind up the session. Okay, fine. I'll upload the table. Okay, thank you. Any? Okay, thank you. Okay, thank you. Thank you for the presence that you listened for the 8 week or 9 week. Okay, thank you. We'll wind up session.